Okay, Nigel, well, we've got our slurry sample now, so can you show us how we can test the slurry on farm and what equipment do we use to do that?
Okay, yes. First of all, it's most important that we get a good representative sample of our slurry.
Right.
There are procedures in the NVZ guidance from DEFRA stipulating that you should take 3 samples from your slurry pit or your tanker to ensure that it is, or that it's been stirred and that it's homogeneous, so that we know we've got a good accurate sample. First of all, we want to look and see what our total nitrogen, phosphorus and potash content is.
Okay.
So for that, we're going to just use a simple hydrometer. We drop that into our
How much do we need?
slurry.
How much slurry do we need to test, roughly?
Enough, about a bucket full should be sufficient. If it's very thin slurry, then you might need a deeper vessel because the hydrometer drops in quite deeply. This one is showing a dry matter content of 6%. So we know from that, from our fertilizer manual, our RB209, if we look at the tables in there, typically 6% dry matter pig slurry is going to have about 4.4 kilograms a cubic meter or per ton of total nitrogen, 2.6 kilograms a ton of phosphate and about 2.8 kilograms a ton of total potash. Using the manual is one way of doing it, but more precisely on the farm we can use a portable test kit,
Okay.
such as this.
And this is available to anyone? Anyone can buy this and use it themselves on farm?
Yes, these are commercially available, cost about a similar amount of money to about 1 ton of fertiliser,
Okay.
so very affordable. They've been tested in the laboratory against laboratory samples and are found to be consistent and accurate.
And the results you compare with the RB209 figures?
That's right, we can compare those and we're actually getting a value of what we've got on the farm rather than using a book value.
Right.
So first of all we have to take
I'll hold that for you.
one sample of the pig slurry in our little 3 scoops full of water. This is bucket chemistry at its best. We then add a reagent to make the reaction.
To create the most accurate chemical reaction, pour 1 scoop of reagent into the black cup that's supplied, then add 1 scoop of the pH neutralizer and drop the whole cup into the mixing tube, tighten the lid on and shake really thoroughly. Take care with the reagent because the acid can damage clothes.
Screw on the lid tightly.
All that's going to be mixed together now?
All that's going to be mixed together. We get a chemical reaction which produces the gas. Screw it on tight, and the reaction of the gas should give us our available nitrogen as opposed to the total nitrogen which we got off the figure, off the book. And you see the gauge is still just
Settling.
climbing up as the reaction. It might take just a few minutes for the full reaction to work.
But it's a quick result.
Very quick
Okay.
and reliable, taking away the guesswork.
So that result you're going to now enter onto this computer program.
Yes,
Which is generally available.
that's correct. I'm going to use the Manna NPK computer program, which is a free download from DEFRA, which will do all the calculations for us to determine how much available plant nutrients we have for the crop that we're intending to grow based on the date that we've spread it, the soil types, the method of spreading, rainfall, and then we can also then add in current fertilizer values, so we then got a fertilizer replacement value.
And you're going to take those values from RB209?
They're based on the RB209 values, but they're all set as defaults into the program, and we can actually add our own values from what we found today using our test kit to get a more precise evaluation for our own farm.
So it's totally site specific to your slurry on your farm on the day that you're going to apply it?
Exactly.
Okay.
So we're becoming as precise as we hopefully can.
Okay.
So we're just adding our details. So we've already added the farm details, so there's the soil type and the cereal crop that we've got. We add in that we're spreading pig slurry, the date that we're applying it, so we're saying that we're going to put it on the 9th of March.
I understand.
The quantity, now we're putting 30 cubic metres a hectare on, or for those that prefer English units, we can quickly change to 2,670 gallons an acre.
Per acre, yeah.
Yep, so we easily revert from one to the other. As I've said, band spreading, not incorporating it. The end of the field drainage is in the middle of February, so we just quickly change the date. We're moderate amount of wind, quite gentle. No, we're not expecting rain today, and the soil type is moist. We've got our slurry analysis, so we said we'd got pig slurry, and it's 5% dry matter that we had from our thing, but we are ammonium nitrate, or the available from our testing that we've just done, was coming out at 1.1 kilograms a cubic metre.
5% is about what you'd expect for a normal slurry sample.
5% is quite thick for pig slurry. Dirty water I'd expect about 1% or lower. It depends how dilute it is. What I would emphasise is that it's useful to keep taking samples from, if you've got slurry from different sources, for example, different houses, different types of animals where the diet might have changed, because it's very diet related. So we know our total N, it's come out with our phosphorus, potash, and the results very quickly calculated that we've applied 150 kilos of total N per hectare, of which the current crop is going to receive 132 kilograms of nitrogen, with a very high efficiency in this case of 88%, which is really good. Total phosphorus 66 kilograms a hectare, of which 33 are available.
Right.
Potash 78 kilograms, 70 of which is available.
Yep.
And some sulfur and magnesium. Total value, I've already inputted today's fertilizer prices to get our NPK values, and it's saying that this application has given us 96 pounds worth of ammonium nitrogen. 173 pounds a hectare is what it's worth.
Quite a considerable contribution then. So a really small amount of bucket science is going to allow us to apply our slurry very, very accurately to the following crop's requirements.
Yes, and we can fine-tune our fertilizer program and optimise our margins for the crop.
I understand. You've shown us how easy it is to test slurry on farm. What should we do if we've got a muck heap that we need to apply as well?
Okay, unfortunately we can't analyse on-farm farmyard manures or from muck heaps. So therefore we've got to go and take a sample and send it to a laboratory for analysis.
And that could be done at the same time as a soil analysis?
Exactly, you could send that, and it is a good idea to bulk the soil and your manure samples together, send them off to the laboratory and benefit from discounted.
So you've got a complete picture of what you've actually got. You can gauge that against what the crop requirement is, and you'll know exactly what to apply.
That's right, and you can then produce yourself a good fertiliser programme for your specific crops. When you're taking a sample of your manure, just like slurry, it's important that you get a representative one.
Okay.
Again, DEFRA in their NVZ guidelines will give you a prescribed way of doing it. You need 10 sub-samples of at least 1 kilogram each.
Okay.
They should be at least 1/2 metre from the surface of the heap, so you need to dig in there.
Right.
And then any lumps broken up, mixed together, and then 2 kilograms sent to the laboratory for analysis.
2 kilos is what you need?
2 kilos. Right. So you're mixing your 10 kilo sample up, making it crumbly, and then sending 2 kilos to the laboratory.
And that needs to be relatively dry in order for that to be tested properly?
No, it just as it comes out of the heap, you want it as representative as it is.
Right,
so, and you put it in a sealed container, plastic bag, and send it to the laboratory. When you get the results back, Again, you can either use the fertiliser manual RB209 to interpret the contribution to the crop, or better and quicker, again, use the Manna computer program.
Okay.